the least positive integer n for which 1 plus I upon 1 minus I whole to the power of n is equal to 2 upon pi secant inverse of 1 upon x plus sine inverse of sine inverse of x, where x is not equals to 0 and x lies between -1 to +1. And since we know 1 plus I upon 1 minus I is equal to I, so I power n is equal to 2 upon pi times of secant inverse of 1 upon x, we can write cos inverse of x plus sine inverse x. And since we got this 1 plus I upon 1 minus I whole power n, let me do it here. 1 plus I upon 1 minus I. So by using our trick we can use 1, 1 and 1 minus 1. So 1 ones are 1 plus of minus 1, that is 1 minus 1 plus I times of 1 ones are 1 minus of minus, that comes plus 1 divided by 1 square plus 1 minus 1 whole square, that is again 2. So we can add this is 0 plus 2I divided by 2, so which is equal to I. So 1 plus I upon 1 minus I value is I, and secant inverse of 1 upon x is cos inverse x. So we use these two properties, and hence I to the power of n is equal to 2 upon pi, and cos inverse x plus sin inverse x is nothing but pi by 2. So here gets cancelled, which is equal to 1. I power n is equal to 1, like I square, I cube and I power 4. I power 4 is, the value is 1, that is the smallest. For smallest integer you will be getting 1. So this is I square is -1, this is minus I, and again I power 4 is 1 you will be getting. So we can say that n is equal to 4 is the least positive integer for which both are equal. So we can go with an option 2.